NEET 2023 checkpoint. Some important chemistry mathematical problem and solve. Solid chapter. First question. Lithium has a BCC structure. Its density is 530 kg per meter cube and its atomic mass is 6.94 gram per mole. Calculate the edge length of a unit cell of a lithium metal. Given Na, that is Avogadro's number, is equal to 6.02 into 10 to the power 23 per mole. Now, given the question, M, that is mass of a lithium molecule, is 6.94 gram per mole, and Avogadro's number Na is equal to 6.023 into 10 to the power 23 per mole. Density, that is rho, is equal to 530 kg per meter cube. This is the change of unit is equal to 0.53 gram per centimeter cube. So calculate the edge length, that is small a, is equal to question mark. So we know density rho is equal to m into z by Na into a cube. Here m is equal to mass of this molecule and z is the atomic number of this molecule, and Na Avogadro's number, and A is the edge length of the lithium molecule. So we know m is equal to 6.94 into 2. 2 is the Z atomic number of lithium molecule by Avogadro's number 6.023 into 10 to the 23 into 0.53, that is rho. Then A is equal to cube root of 4.53 into 10 to the minus 23 centimeter to the power minus 3. A is equal to 3.52 into 10 to the power minus 10 centimeter, that is 352 picometer. We know 1 picometer is equal to 10 to the power minus 10 centimeter. Next question. The ionic radius of A plus and B minus ions are 0.98 into 10 to the power minus 10 meter and 1.81 into 10 to the power minus 10 meter. The coordination number of each ion in AB is. So we know that from the question, ionic radius of cation, that is A plus, 0.98 into 10 to the power minus 10 meter, and ionic radius of anion B minus is equal to 1.81 into 10 to the minus 10 meter. So we can calculate coordination number of each ion in AB. At first, now we have R plus by R minus, that is ratio of cation and anion, is equal to 0.98 into 10 to the minus 10 meter by 1.81 into 10 to the minus 10 meter. So is equal to 0.5414. If radius ratio range is in between 0.441 to 0.732, ion would have octahedral structure with the coordination number is 6. Coordination number, the number of points of attachment between the ligands and the atoms. When the central atoms bounded by the ligands, this number of ligands attachment to the central atom, the number of atoms is called coordination number. So we can calculate easily coordination number of A plus and B minus ions. Third question, in calcium fluoride CaF2 having the fluoride structure, the coordination number of calcium ion Ca2 positive and fluoride ion F negative are. So at first Ca2 positive is equal to 8 and F negative is equal to R. So that is calcium fluoride structure. This is a AB2 type. It has CCP, cubic centered. Arrangement in which C2 positive, that is cations, occupy FCC, that is face center cubic, and F negative, that is anions, occupy all the tetrahedral voids. That is Ca2 positive is equal to FCC, and this is coordination number is 8 and F negative is equal to 4, that is a tetrahedral voids. Next, we can calculate the vacant space in BCC lattice cell. BCC means body centered cubic structure. At first, we have seen that a body centered cubic unit cell contains two particles. We think radius of a particle is R. So total volume of the particle, that is 2 into 4 by 3 pi r cube, because here particles denotes the sphere of structure, that is a circle. So the length of this circle is pi r cube, 4 by 3 pi r cube, and here two atoms, body centered cubic unit cell contains two particles. Then the total volume of this particle is 2 into 4 by 3 pi r cube is equal to 8 by 3 pi r cube. That is equation number 1. Vertex at the edge of a body centered cubic cell do not touch to each other, but they do touch the particle at the body center. Here we see this is the structure of the BCC structure, and here the central atom touch each other, but the particles of edge here is not touch, but centered cubic cell, the centered particle touch of this edge particle. Then we think length of the edge unit cell is A from the AD is equal to 4R. We see this is the circle, this is the circle, this is the circle. So here the center of the atom, here total radius of this circle 2R, here R and here R, that is a half of this radius. So total length of 3 molecules is equal to 4R. This is the equation of 2. Next, we can calculate ABC triangle, that is right triangle. AC is equal to root over AB square plus BC square is equal to AB means edge length, that is A square, plus BCO same, A square is equal to root over 2 into A. This is the equation number 3. Then another right triangle ACD, AD is equal to root over CD square plus AC square sum root over A square, plus here we can calculate AC sum root 2A. So 2A square is equal to root 3 into A. This is the equation number 4. From 2 and 4, equation 2 and 4, root 3A is equal to 4R. Root 3A is equal to 4R. Here equation number 2, AD is equal to 4R. Here AD is equal to root 3A. So we can same this length AD, root 3A is equal to 4R. Here A is equal to 4R by root 3. So volume of unit cell is equal to, this is the 3 length multiplication A cube. This is the length, width and height, 3 multiplication. So this is same length, that is A. Here A cube is equal to A is equal to 4R by root 3 whole cube is equal to 64R cube by 3 root 3. Packing fraction, this is 8 by 3 pi R cube. Total volume occupied by number of atoms by volume of unit cell, that is 64 R cube by 3 root 3 is equal to root 3 by 8 pi is equal to 0.68. So percentage of occupied volume, that is packing fraction, 68%, and vacant space is equal to 100 minus 68 is equal to 32%. So many particles touch each other and the solid molecule, here we can see this is a not vacant space, but originally every solid molecules occupy vacant space. So we can easily calculate vacant space of a molecule in FCC, BCC structure